Hi guys, welcome to another one of my Dowlathreivision series, and at number 24 we're going to deal today with how a Vernier caliper works. Now a Vernier caliper is an instrument used to measure lengths, and we use it predominantly for measuring, let's say, the external diameter of a beaker, right? If you wanted to get the thickness of a book, things like that. Now it is advantageous in that it is more precise than a ruler because it measures up to 2 decimal places on the centimeter scale, and it makes that its smallest reading is 0.01 of a centimeter. So if you look at the picture, it basically shows you what the device looks like. You have here being the main scale, and then you would have where the screw clamp is turned, and there is a wheel that slides a smaller scale on the main scale. The smaller scale here is called the vernier scale, and you place whatever instrument you want to measure here because the jaws slide apart, right? So if you want to measure inner dimensions, use the top jaws, but outer dimensions, use the bottom jaws. And as the screw clamp is turned and you slide the vernier scale along the main scale, it results in the jaws being open and further apart. When you have ensured that your entire object is between the jaws, you then screw down the clamp to make sure it is fixed. Now when you want to measure it, this is what the main scale and the vernier scale looks like. Now the main scale can be measured in centimeters, but there are some older vernier calipers who use the millimeter scale, right? So just be careful with your instruments. So you're looking at the main scale, and the main scale is just like your ruler. So in a ruler, the smallest measurement is 1 millimeter, right? So if you're looking at this scale here, I have 3.1, 3.2, 3.3, 3.4, 3.5, etc. to get all the way to 4 because my main scale is just like a ruler. Now my vernier scale is found by taking the smallest division between 3 and 3.1, let me say, which is 1 millimeter, and dividing it into 10 smaller divisions. Because many times when, like, let's say the zero reading of the vernier lies between 2 of your main scale readings, then it means that your value is not just 3.3, but it is 3.3, let's say 5 or 3.36. But because you have no smaller scale between these two readings here, these two markings here, then you have no clue as to what specifically is your value. So what we normally do is that we consider firstly where the zero lies. The zero, so your first part of your reading is the value on your main scale immediately on your left hand side of zero. So your zero on your vernier scale, you're going to firstly check between which two readings on the main scale it aligns, and it will be here between 3.3 and 3.4. So on your left hand side it works out to be 3.3. So the value is 3.3 something, right? Now to see exactly where, you're going to look for the vertical alignment between your main scale and your vernier scale. So that works out here to give you 4. So it becomes 3.34 centimeters, right? So let's apply this procedure here now. So you are looking to see right. So basically, guys, whenever you are considering how you are doing your measurements, you are looking to see where your zero scale aligns between which two readings on your main scale. You check and see which value it is to the left. So in this case, it was 3.3 because you're looking where your zero scale, your zero value aligns between which two values on your main scale here. So it would take 3.3 to your left. Then you want to check and see that where there is now a vertical alignment of the vernier and the main scale. So that was 4. So the value turns out to be 3.34.